Hey there YouTube, Ryan from Slow Your Roll here. Today I'm going to be doing a two-part video. The first part I want to cover the Basecamp's electrical system and some of the different packages that Airstream offers. The second part of the video I'm going to be installing the Renogy 2000 watt inverter so that the Basecamp will finally be energy independent, assuming I don't F it up or the sun stops working. So when you're at the dealer, you're going to be presented with three options as far as solar and battery upgrades. The first one is no solar. It comes with two lead acid 100 amp hour batteries. No hook. It does come with the solar hookups on the roof, so that if you want to add panels after the fact, you have the option to do that. This package is predominantly targeted towards folks that are going to be spending the majority of their time at an RV park or a campground that has dedicated 30 amp service, or even mooch docking. I wouldn't recommend purchasing the upgraded solar options if this is what your typical camping lifestyle is going to be. However, when it comes to lead acid battery, there's a level of maintenance and off-gassing that occur that, in my opinion, it's worth the money to upgrade to an AGM, which is a maintenance-free option. It has a similar discharge rate, 50%, same thing as lead acid batteries, but you don't have to maintain them. You can put them in enclosed and you don't have to vent them off, so it's a little bit safer, especially if your batteries are inside the coach as they are in the Basecamp. For the second option, I pulled this PDF off of one of the Airstream forums, but it gives an accurate depiction of what equipment is included in that second solar upgrade. So starting from the left is your Victron MPPT controller, which displays the data off this second item here, which is your solar controller, also by Victron. It does not have Bluetooth capabilities inherent in the piece of equipment, but it is a 150/35 MPPT solar controller, which regulates how much energy comes in from your solar panels. So this is reticent on the 21 and newer models, and then down here you can see the older equipment and solar setups for the 20 and earlier models. In addition to this equipment, you get two 90-watt solar panels mounted to the roof and two 100 amp hour AGM batteries. I highly suggest the Solar Select package for those who are going to be balancing their time between RV parks or RV campgrounds and want to explore a little bit outside. You're not going to get as much as the capacity out of the AGMs as you would the Lithium, 50% versus 100%, but it is a cost savings of about $2,500 when you factor in battery cost and labor. And then finally, the third package is everything you got in the Solar Select package: the two 90-watt solar panels on the roof, the Victron battery monitor, and the Victron MPPT controller. The only change is you take the AGM batteries out and you add lithium. This is targeted for those that are predominantly going to be boondocking, spending their time off-grid, that want to maximize the lifespan of their batteries. It's a very expensive package, so I think you want to make a deliberate choice as to what your camping lifestyle is going to be before you opt for it. Me personally, seeing that most campgrounds and state parks and national forests are kind of booked up right now, I like to go off the grid. I like to be separated from I like to be separate from crowds. So the lithium package was definitely worth it in my opinion. Alright, let's talk inverters and converters. So your Airstream is going to come standard with a converter. The 21 and up models have one that's actually configurable, or you can change it. If you add lithium batteries versus AGM, there's just a switch that you have to toggle over. Previous models, they had to take the original converter out and put a new one in. So that's an advantage of the newer 21 and the newer 21 Basecamps. What the converter does is it takes that 30 amp, converts it down to 12, and charges your batteries. You can't use your 120 volt just on your batteries. That's where this inverter comes in. So what this is going to do is this is going to do the complete opposite. It's going to take your 12 volt batteries, or whatever your battery bank is, it could be 24 volt, and it's going to change it so that you can run 120 volts off it. I opted for a 2000 watt inverter. What you want to do first is you want to do a power audit and figure out what appliances you're going to be running. And if you've got, for instance, I have a Fellow Stag hot water kettle to boil water. That is 1200 watts. All right, so you want to buy something that exceeds the highest load that you're going to run. So I opted for 1200. We don't have any other appliances that are going to be in excess of 1200. The way the inverter is set up is you've got two ends. On this end, you've got the hookups for your positive and negative cables that you're going to run to the batteries. And you also have your fan to cool this down. Okay. On the other end, you've got your on-off switch. You've got 3 outlets. And then you've also got a space to hardwire a 120 volt system. So for example, I want to run all the plugs on the Basecamp, which go to a specific breaker. In theory, I can remove that 10 AWG cable from the breaker, put it in a new breaker, and then run it directly into here so that when the inverter's on, I can run just those outlets. Okay, I'm going to attempt to demonstrate this on the table because once it's in the actual battery compartment, it's going to be tough, or it's going to be tight space and it's going to be tough to explain. So starting off with our 2000 watt inverter, I called Battleborn and did some research online using American Wire Guide. What's recommended for the 2000 watt inverter is a 1-aught wire. So starting with the positive terminal, I've got a 1 foot 1-aught wire coming to a 200 amp A&L fuse. From the fuse, I've got a 2 foot positive that's going to connect to the positive terminal of the battery. On the negative side, I've got a 3 foot 1-aught wire running out that's going to connect to the negative on the battery side. If you look at my 2 batteries, not to scale, they're wired in parallel, meaning negative to negative, positive to positive. So when I actually get this all mounted, I'll take the positive lead, mount it to the positive side of one battery, and I'll take the negative lead and attach it to the negative of the other battery to make the connection. Now originally I wanted to put it under the bench here to keep it out of the way. There's a lot of unused space below here. Unfortunately, the inverter is too long and this pole gets in the way right here. So the next option is there's a board that runs back towards the wall. So I have to take this off in order to see if there's enough room in the back, because the 2 things you need to worry about is 1, that the fans have enough space to circulate air and to keep this to a cool operating temperature. The second issue is making sure those wires, which are not as flexible as the smaller ones, will actually fit back in there to connect to the battery. So I'm going to take this apart and we'll see what we can do. So this is the board I'm going to attempt to attach the panel to. It's not that thick. Currently it's only held in place by 2 L brackets at the bottom and nothing at the top. So what I did was I purchased 2 additional L brackets that I'm going to mount up here to add some structural integrity to this board, because as you can see it's pretty wobbly as it is right now. It's held in place with the board that I just removed by 2 screws. So I'm going to take this board off, do some measurements outside the RV to see if I've got the actual clearance to get the inverter and the wiring into the battery bank here. Alright, so I removed the side panel that used to be over here. to give us some more room and to actually set the brackets and take the measurements to mount the inverter to the board. The next thing we want to do before we put that wall back in is, you can see here, Airstream installs the batteries in parallel with 6 AWG wire. 6 AWG wire is probably, how do I say this? It's bordering ineffective. So it's obviously going to work, but because the batteries are so close, and because the breaker box and circuit panel are right over here, they can get away with it. But the longer the wire, the larger the load, the bigger the wire you want. So we removed the 6 AWG wires and put on the 1/0. So the next step is we're going to put that panel back in. We're going to measure where the wires are going to go through, and then cut a hole in the side of it to allow the wires to feed through. Board out, what I did was I templated the holes for the brackets of where the inverter was going to be screwed into the board. The complaint I do have about Renogy, and I've seen other people mention this as well, is the brackets are very inaccessible, as in the inverter itself flares out beyond where the screws go in. So what you have to do, like I did, is I started the screw, and then I'm going to have to take a short 90-degree screwdriver to tighten it up once it's in there, because you can't fit a long screwdriver or drill bit in there. In addition, I drilled 2 feed holes, and that's where the wires are going to go through, to give them enough flexibility to get to the battery. So next I'm going to mount the inverter, I'll feed the wires through, and then we'll finish up the connections. A little update. So you see the negative line coming in through the top guide hole, or drilled hole. The positive cable is coming through. It's connected to the 200 amp A&L fuse, and then I'm going to connect another leg of the positive from this end of the fuse to the positive end of the battery here. And I'll take this negative end, and that's going to go to the other battery. That way we get an even draw across both batteries. Alright, so here's the almost final product. So positive connected to the A&L fuse, going to the positive terminal of the battery, the negative coming out of the wall, connected to the negative terminal of the battery. And then what I did was, in order to avoid frying my circuit board, I removed, so you can see this, the positive end, just to make sure when we turn the inverter on, nothing goes wrong. So once that's on and I don't see any issues, I'm going to connect that back up and make sure the entire system is working. Here's the moment of truth. Red bad, green good. And we're up. Alright, let's see if we've got something to plug in here just to make sure it works. Alright, so I brought in a space heater that I have to test out to make sure that the inverter is actually working. So this thing is rated at 1500, and that's probably on the high setting. So we're probably looking at about 900 to 1200 watts on the low setting. So it's plugged in, the inverter's on, so we're just gonna turn the on button, or press the power button here, and that's the high setting. Turn it over to low, and we've got power. Alright, so here's the final product. Couple of safety notes. Again, when you're working with DC, obviously you want to work, you don't want to risk the positives and negative wires touching each other. If you don't know why, I mean, imagine life as you know it stopping instantaneously and every molecule in your body exploding at the speed of light. Well, actually it's just a risk of shorting out the battery. But all drama aside, is that when we talked about the MPPT charge controller that comes with the Airstream package, the solar package, it comes with the Blue Solar, which is the cheaper model. It still does the job. However, I had a smart solar charger on my other rig, and I wasn't using it, so I just took it off and put it on here. The advantage of that is I can actually, it's got an internal Bluetooth that I can look up on my phone, and I can show you that later. The other one, you'd have to rely on the MPPT monitor that's mounted over here. So we'll take a look at that real quick. So I don't know if you remember my first video, I talked about the interior, and I erroneously identified this as a battery monitor. Since the other MPPT solar controller was not Bluetooth, it relied on this to give you your displays. So to give you your amps coming in, your battery state, whether it's float, bulk, how many kilowatts you're using, how many volts are coming in from the solar. So by virtue of installing the Bluetooth one, I've kind of rendered this obsolete, and we'll replace this eventually with this product. All right, so this is an actual battery monitor. You'll notice that it comes with a shunt, and you need that in order to have an accurate reading of what your battery is drawing from. So when I install this system, you're going to install one leg of the negative, so the negative leg coming directly off the battery to one end of the shunt. All of your other negatives, more accurately, your negative going to your bus bar is going to be connected to this one. So that's going to read everything that's drawing power from the battery, and it'll give you a percentage. Why that's important is if you have an AGM or lead acid battery, you don't want to draw less than 50% of the battery or you risk damaging it. It's less important for a lithium battery because you can pretty much draw that almost all the way down to zero without having to worry about it. So this isn't a fix that I need to make immediately. I'm not that concerned about it, especially since I can take a look at it on my phone. But it's just a good thing to have and to be aware of. So the thing I like about Victron products is they're all interoperable and they all connect to the same app. So once you open to that, so I've got the battery monitor, the top one you see, is actually because my other rig is parked about 4 feet to the right of us. So it's picking that up as well. What I have installed in Basecamp is the Smart Solar. So we're going to take a look at that. And that's going to show us what's actually coming into the solar. Up here is you've got 19.93 volts with a 3.3 amp current. And then down here is the status of your battery. So I'm at about 13.5 and 4.7 amps, and we're in a float stage. So what it does is in a float stage, it's going to throttle this down. So it's not going to bring in as much voltage to charge the battery up because the battery is to its full capacity. So if you saw that down in bulk, you would see the voltage go up. All right. So just again, it's a cool thing to have, especially if you can have it in your phone. It is Bluetooth, so you have to be relatively close to the vehicle in order for it to pick up that Bluetooth signal. You can't monitor it remotely from far away, but still a great product. So the panel is connected back, the inverter's off, and we're going to be disconnecting the battery as well because we're going to be leaving the trailer. But it looks pretty good. It's not as... I wanted it to be a little bit more hidden, but at the same time I wanted access to these outlets right here. So again, the long-term project is to hardwire the GFCI outlets throughout the camper. They're all in the same I don't know, circuit, I guess you would say, but they're all connected to the same thing. What I need to kind of look at though is it may also be on a redundant circuit to the water pump and heater. So those things are actually powered by the battery on a 12-volt system, which allows you to go off grid. However, I just want to make sure I don't do any damage or incorrectly mount those wires without doing something that I don't want to do. But again, happy with the results. And then we're going to put this thing to the test when we go beach camping down in Texas next weekend. Hey, thanks again for watching this video, covering the Basecamp electrical system, the different solar packages you can purchase, and watching my attempt at installing a Renogy 2000 watt inverter. Time will tell how effective it was. I do want to give a shout out to a couple of YouTube channels, Will Prowse and Explorers Life. If you haven't seen these two individuals, they are extremely eloquent at explaining complicated electrical systems. They do comparisons, they do battery tests, wire sizes. Explorers Life provides a calculator which can help you determine how many solar panels you need, what size gauge wire you need, how big your solar controller is. I mean, he does a fantastic job. So thank you, gentlemen. Before watching those videos, I had zero knowledge of basic electrical systems, whether that's DC or AC. And now I'm confident that I'm just dangerous enough to get the job done myself. So shout out to them. Again, thanks for joining me, and hope to bring you along our beach adventure next week. We're planning on going down to Texas and doing some beach camping, stopping at some harvest hosts along the way. See you then.